Hi dear students, welcome you all to the brilliant group of institution. Here we are discussing the chapter coordination compounds from your grade 12 Valence Bond Theory, VBT. It's one of the most important concept from your grade 12, the chapter coordination compound. There are a lot of applications for VBT, Valence Bond Theory in coordination complexes. We can calculate what are the applications of VB theory. Let's discuss. We can calculate what is the shape of a complex, coordination complex. Whether it is tetrahedral, whether it is square planar or octahedral. Mostly we are discussing in the chapter three type of structure. Octahedral, square planar. Mostly complexes are existing in this structure. More are there, but mostly complexes are existing in these three structure. Octahedral, tetrahedral and square planar geometry. And we can find out whether it is an inner orbital complex or outer orbital complex. Let us tell you what is later. And you can say whether the complex is low spin or high spin complex. And you can say the complex whether it is paramagnetic or diamagnetic. Their magnetic behavior, everything you can say related to the VB theory. Let's go to the concept. So before answering VB theory, we need a set of concepts. First one. If you know the coordination number of a complex, what is meant by coordination number? I'll give you one of the example here. The complex is NiCl4 2-. Here, which is the metal atom? Nickel is the metal atom. Done. It is connected to chlorine, right? Cl. You know, chlorine is a monodendate ligand having one donor atom. So total 4 chlorines are there, right? 4 chlorines are there. You know, each chlorine can make one sigma bond with the metal atom because chlorine is a monodendate ligand. It's having one site. It can make only one sigma bond with the metal atom. One chlorine, one sigma bond. So total 4 chlorine, 4 sigma bond. What about here? Here the central metal atom is iron. The surrounded ligand is cyanide, right? Cyanide. So how many cyanides are there? 6 cyanides are there. 1, 2, 3, 4, 5, 6. Okay, I'm just writing cyanide, okay, Cn. Because carbon is need to make a bond, right? You know why they are making single bond? Because cyanide also a monodendate ligand, a unidendate ligand. It can make only one sigma bond. What about here? Cobalt is there. It is surrounded by how many chlorine? 2 chlorines are there. You know, chlorine is a monodendate ligand, will give 2 sigma bond, means 1, 1. En, you know the ligand En, ethane 1,2-diamine, it is a bidendate ligand. En is a bidendate ligand. So, if you consider one En, it can give you 2 sigma bond. Because bidendate mean having 2 donor atom. So, one En can give you 2 sigma bond with the metal atom. There are 2 En group. Let me take one more. It also can give 1 sigma bond, 2 sigma bond. Okay, so dear all, what is mean by, let me come to what is the definition of coordination number. Coordination number means it is the number of sigma bond. It is the number of sigma bond around the central metal atom which is created by the ligand. Which is the metal atom here, nickel. How many sigma bonds are there around this nickel? 1, 2, 3, 4. So the coordination number is equal to 4. What about here? The metal atom surrounded by 1, 2, 3, 4, 5, 6 ligand. So the coordination number is equal to 6. Whereas here 1, 2, 3, 4, 5, 6. So coordination number is equal to 6. So what is coordination number, dear student? The number of sigma bond around the metal atom which is created by the ligand is called coordination number. Mostly they will ask you 4 and 6. The coordination number, if it is equal to 4, 2 structures are possible. All of you, if the coordination number is 4, 2 structures are possible, either tetrahedral or square planar. Why? Let me tell you. What is the tetrahedral geometry? You know very well. Tetrahedral means, you know, tetrahedral. Tetrahedral means metal atom, 1, 2, 3, 4 ligands. This is the geometry called tetrahedral. Can you able to understand? 1, 2, 3, 4. 4 sigma bonds are there. Therefore, 4 here. Next structure is called square planar. What is square planar geometry? Metal atom 1, 2, 3, 4. This geometry is called what? Square planar. See, in tetrahedral geometry and square planar geometry, what is the number of sigma bond? 4, right? So coordination number, if it is equal to 4, either the structure is tetrahedral or square planar. Then, so how we can find that which is tetrahedral and square planar? We need VB theory, don't worry. If the coordination number is 6, only one structure. If the coordination number is 6, 6 means how the structure is possible. Let me just write here, all of you. If coordination number is 6, for example, this one, iron is the metal atom, 1 cyanide, second Cn, Cn, carbon is the connection, okay, Cn, Cn and Cn. This is the geometry. Here you can see this is called square bipyramidal. Square bipyramidal. You know, square bipyramidal structure is also called octahedral geometry. Square bipyramidal is also called octahedral. So how many sigma bonds are there on this iron? 1, 2, 3, 4, 5, 6. If the coordination number is 6, you can ensure that structure is octahedral. Structure is octahedral. So dear all of you, mainly complexes are existing in 3 structure: tetrahedral, square planar and octahedral. How you can confirm the given complex is tetrahedral? If the hybridization is sp3, what is mean by hybridization? Mixing of orbital. S orbital, p orbital, d orbital, you can mix it. That's called hybridization. If the hybridization is sp3, the structure is tetrahedral. If the hybridization is dsp2, it's called square planar. All of you, study carefully. If the hybridization is sp3, structure is tetrahedral. I will tell you how to calculate the hybridization later. If the hybridization is sp3, tetrahedral. If the hybridization is dsp2, is called square planar. If the hybridization is sp3d2 or d2sp3, both are octahedral. sp3d2 or d2sp3. All of you, please learn this table now. Please study the table now. Now, pause the video, study the table. I'm going to the next topic. In octahedral complexes, some special cases are there. I told you, octahedral complexes, you can say that either the hybridization is D2sp3 or the hybridization is sp3d2. Dear all, here, what is the difference between D2sp3 and sp3d2? In this hybridization, they took inner d orbital. Yes or no? Inner D, then S, then P. So in D2sp3 hybridization, they took inner d orbital. Therefore, they are also called, this type of complexes are called inner orbital complexes. Inner orbital complexes. Whereas sp3d2, what is the speciality in sp3d2? For their hybridization, they took outer d orbital. They took initially S, then 3p orbital, then only they enter into the outer d orbital. Therefore, these complexes are called outer orbital complexes. Outer orbital complexes. Dear all of you, if the, we are dealing with octahedral, okay? The other one is over. If it is tetrahedral, only one hybridization, sp3. If it is the hybridization dsp2, square planar. That's over. But in octahedral complexes, 2 types are there. What are they? D2sp3 and sp3d2. If the hybridization is D2sp3, they are called inner orbital complex because they took inner d orbital. If the hybridization is sp3d2, they are called outer orbital complex because they took outer d orbital. One more point, all of you. If the orbital is of the complex is inner orbital complex, they also called low spin complexes. Low spin complexes. Inner orbital complexes are also called low spin complexes, and outer orbital complexes are also known as high spin complexes. Keep in mind, high spin complexes. One more idea. Everything we can discuss through the example. Okay, one more idea. If there is a low spin, if the complex is low spin, that means there is a presence of strong field ligand. If your complex is a low spin complex, most of the cases there is a presence of strong ligand. If the complex is a high spin complex, there is a weak field ligand presence. Weak field ligand. All of you please study the concept, the order first of all. If the complex is octahedral, two type of hybridization is possible, D2sp3 and sp3d2. D2sp3 complexes are also called low spin complex, right? Means inner orbital complex. They are also called a low spin complex. If it is a low spin complex, there is a presence of strong ligand. Come to this part. If the hybridization is sp3d2, they are called outer orbital complex. Outer orbital complexes are also called high spin complex. High spin complex mean there is a presence of weak ligand. What is that strong ligand and weak ligand? We need to know a series is called spectrochemical series. Dear student, spectrochemical series is the arrangement of various type of ligand in the increasing order of their crystal field splitting power. It's actually a power, okay? There are two type of ligand you can able to see, weak field ligand and strong field ligand. Which all are weak, which all are strong? See, by looking this one, we cannot able to understand which is strong and weak, right? There is a rule they given. In spectrochemical series, you can see almost at the center water, right? H2O, aqua, we'll call aqua, right? If the water and the species which is located left side, including water, the left species, which mean iodine, bromine, sulfide, SCN, thiocyanate, chloride, nitrate, fluoride, oxalate, all these ligands, including water, all these ligands are called weak field ligand. But there is a small exception case. The species which is present left of H2O, all are weak ligand, no doubt. But H2O, most of the cases weak, but some cases they are strong. Just note it all of you. In which all cases H2O act as a strong ligand. Let me tell you once again. Normal cases, water, aqua, H2O ligand act as a weak field ligand. In few cases, mostly three cases, if the metal atom, for example, that is cobalt, copper or nickel. Suppose the central metal atom in the given complex is copper, cobalt or nickel. If they are suppose in +3 oxidation state in the complex, in such cases, water if it is there, you have to consider it as a strong field ligand. Let me conclude all of you. What is a spectrochemical series? By looking the spectrochemical series, you can say which all are strong and weak ligand. Generally, including water, all the left species are weak field ligand. After water means NCS up to CO, all are strong field ligand. Okay, all are strong field ligand. Water, most of the cases it is weak field ligand except three cases. In cobalt, copper and nickel, suppose they are the metal given in the complex. If suppose they are in the +3 oxidation state, in such cases they are act as strong field ligand. Which one? Water. Okay. So dear all, let us go to the concept. Most of the NEET examination, JEE examination, entrance examination and for your board examination, they will prefer some certain ligands from this one. Most of the cases, dear all of you, they will ask you, most of the cases the strong ligands are NH3. You can see that where is NH3? NH3C, the right part, strong ligand. Another one CO, where is CO? Carbonyl. Another one cyanide. You can see cyanide. This is the most common. Sometime EN also. Okay, EN also they will ask. These are the common ligands they are using in the complexes. Which one? Amine, cyanide and carbonyl. These three ligands mostly they will use if they comes treat it as a strong ligand. Okay, and normally what are the weak ligands they will give for exam? Weak ligand. Weak ligands are commonly aqua, water. I told you water, what is the case? Normal cases, they are weak, except these cases. And halogens like fluorine, chlorine, bromine, etc. Halogens are belongs to weak field ligand. You can see iodine, bromine, or chlorine, fluorine, all are weak field ligand. So all of you, there are two type of ligand, strong and weak. Strong ligand, some few examples we are discussing. You should know that series very thoroughly. I'm just saying the most common. Okay, strong ligands are amine, CO, and cyanide. Weak field ligands are generally aqua and halogens. Okay, these are weak ligand. And what is the specialty of, or if there is a strong ligand, what happens? Dear all, if there is a strong ligand in your system, the electrons undergo pairing. If there is a strong ligand in your complex, the electrons undergo pairing. Outermost electron come inside and they will pair up. If there is a weak ligand, nothing happen. Electron does not undergo pairing. That is the difference between the presence of strong field ligand and weak field ligand. If there is a strong ligand present, electrons undergo pairing. If there is a weak ligand, no change. Clear all of you? Let's go to the theory. So I told you only few things now. According to VB theory, by looking the hybridization, you can say the geometry of the molecule. By octahedral cases, two different concepts we studied. And what is spectrochemical series, strong and weak. If you know this idea, we can able to answer more concept or more content related to a complex. All of you, I'm starting with the first example. You can able to understand so easily what is the concept. I have the complex hexaamine cobalt 3. Those who don't know the IUPAC nomenclature of coordination complex, we already made a video before. All of you just look into the video, then come to the topic VB theory. This is the complex given. Okay, we can calculate the entire concept regarding this complex. First of all, and here all of you, if you want to know, I told you mainly we are using VB theory to explain the shape of the molecule, means the complex, to say whether it is inner or outer orbital complex, to say whether it is low spin or high spin complex, to say the paramagnetic or diamagnetic, etc. Okay, so I'm going to apply the VB theory, valence bond theory, for the complex. Valence bond theory having total 3 steps. All of you, valence bond theory having total 3 steps. Okay, first step number 1. What is step number 1? Step number 1 is write the ground state electronic configuration of the metal atom cobalt. Here the metal atom is cobalt, right? In every VB theory, in every application of VB theory, when you are applying VB theory, first step number 1, write the ground state electronic configuration of the metal given in the complex. Here the metal is cobalt. What is the electronic configuration, dear student? Up to atomic number 30, at least up to atomic number 30, up to zinc, we should remember. Okay, sometime they will give you the atomic number, sometime not. So very careful. Cobalt atomic number is 27. Cobalt to 27. What is mean by ground state electronic configuration? Their normal state, right? 27. Most of the complexes they will ask you for your exam, 20 to 30 in between. 27. How you can fill that electron in electronic configuration? You know, 1s2, 2s2, 2p6, like that. We don't have enough time. No need to write everything. Let me tell you. 27 means you can write 4s2. You know, 1s2, 2s2, up to it will reach at 4s2. You know, 4s2 mean up to 20 electron completed. If you write 4s2 directly, that means up to 20 electron it's completed. Do you know 20 electron, that is calcium, right? Up to calcium completed. If you write 4s2. Normally argon is there. Okay. And after 20 electron, you know, total atomic number 27. So 27, right? So remaining 7 electron will goes to 3d7. So 27 electron cobalt, what is the configuration we are writing? 4s2 3d7. Why we wrote 4s2 at the last? Because that is the outermost electron orbital. Suppose the atomic number is 26. How you will write, dear student? 4s2 3d6. Means 4s2 mean 20 electron over. Remaining electron fill in 3d. Suppose the atomic number is 28. How you will fill, dear student? 4s2 3d8. That's it. Hope you clear that point. Okay, so 27 electron that we completed as a ground state. Ground state mean normal state. Let me go to step number 2. Step number 2 represent the excited state. Excited state of cobalt. Excited state in the sense, please calculate the oxidation state. That we did already in the part 1 video of coordination compound chapter, okay? How to calculate the oxidation state of cobalt in this complex? Cobalt oxidation state directly we don't know. Let me take it as X. You know, amine is a neutral ligand, charge is 0. Overall charge of the complex is +3, right? If it is a neutral compound, you will write overall sum is equal to 0, but it is a charged compound, therefore +3. So X is equal to +3, means oxidation state of cobalt is +3. So cobalt is in 3+ oxidation state. What is the meaning of 3+? It has to lose outermost 3 electron. So dear student, this is the electronic configuration. Outermost, how they can remove 3 electron? 2 electron remove from 4s first of all, then 1 electron from 3d. What is remaining? 3d6, 3d6 and 4s 0. Correct all of you? Let me just draw the 3d orbital. You know, 5 d orbitals are there. 6 electron, how you can fill? 1, 2, 3, 4, 5, 6. And s orbital is there, no electron. All of you, I'm repeating once again. What is step number 1? In step number 1, we are writing what is a metal atom? Cobalt. We wrote the electronic configuration, ground state electronic configuration of cobalt. Atomic number is 27, so we can write 4s2 3d7. Step number 2 is the excited state. Excited state is nothing but just calculate its oxidation state. We calculated as +3. So cobalt 3+ mean it has to lose outermost 3 electron. When it remove 2 electron from here and 1 electron from here, remaining is 3d6 and 4s 0. That electron I filled. Hope you clear step 1 and step 2. I will go to the last step. What is step number 3? Dear all of you, step number 3. In step number 3, what you have to do now? Identify the ligand which is given in the complex. What is the ligand given in the complex? Amine. All of you, amine is the ligand given in the complex. I told you a set of ligands strong and weak. Amine, cyanido and CO, carbonyl. These are very strong ligand. We should know the spectrochemical series, okay? This is a strong ligand. And I told you what will happen if there is a strong ligand presence. Electrons undergo pairing. All of you, the electrons undergo pairing. What is that meaning of pairing? Okay. I'm just writing the 3d orbital and 4s orbital once again. You know what is 3d orbital? Total 5 are there and 4s is free. I'm going to pair the electron. Pairing is nothing but the outermost electron bring to inner side. That's it. These 2 electrons already paired, right? Okay. And these 2 electron bring together. It's paired. These 2 electrons also paired. This is called pairing. Outer unpaired electron bring inner and pair it. 2 like that. Okay dear all. Step 1, step 2, step 3 over. Now after that you have to check. Step 1 ground state over. Step 2 excited state over. Step 3 you identify the ligand and pairing is done. Suppose it is a weak ligand. Nothing to do. Just copy this one because pairing won't happen. Okay. Now total there are 6 amines, right? Total 6 ammonia means amine ligands are coming to your complex. Dear all, if there are 6 people, suppose 6 neighbors or your relatives are coming to your home, your father or mother, your parent will provide around 6 seats them, right? 6 vacant seat will provide, right? Similarly, if 6 amines ligands are coming to your complex, you have to provide or the metal need to provide 6 vacant orbitals to occupy the ammonia. So 6 amines are coming to your complex, you have to provide 6 vacant orbital. At present, how many vacant orbital you have? 1, 2, 3. Not enough. We need 3 more. Dear student, after 4s orbital, we have 4p. If you need more, take 4d. What is p orbital? Total 3 are there. What is the point all of you? Total 6 amines are coming to your complex. If 6 amines coming to your complex, you have to provide total 6 vacant orbital. So I took after 3d, 4s is not enough, I take 4p also. Alright, then those vacant orbital you can represent by like this across. First, second, third, fourth, fifth, sixth. These are the 6 orbital which is occupying by ammonia. Those orbital you please mix it. That is called hybridization. What is these 2 orbital? D orbital, right? D2. 2 D orbitals are there. What is this orbital? 1 S orbital. What is these 3? P orbital. P3. What is the hybridization you are getting? D2sp3. We said so many things regarding D2sp3 hybridization before. All of you, if the hybridization is D2sp3, structure is octahedral. If the hybridization is D2sp3, structure is octahedral. In D2sp3 hybridization, you see they took inner d orbital for the hybridization, right? They took inner d orbital for the hybridization. Therefore, they are also called inner orbital complexes. Inner orbital complexes. I told you, inner orbital complexes are also called low spin or high spin. Low spin. Inner orbital complexes are also called low spin complexes. One another. I told you, if there is a low spin complex, if it is a low spin complex, most of the cases there will be a strong ligand. Can you see? Amine is a strong ligand. Strong ligand. Low spin complex is nothing but, dear student, the inner orbitals will be paired. Inner orbitals will be paired. Such kind of orbitals are called low spin complexes. If it is not paired, mostly they will be high spin. Why they are pairing? Because there is a strong ligand. Therefore, I said, if it is a low spin complex, there will be most cases there will be a strong ligand. So you got the hybridization, right? D2sp3. You got the shape, right? Octahedral. You got inner or outer, right? Inner orbital. You got low spin or high spin, right? Low spin, right? Strong ligand presence or not. One more thing you can say about this complex, whether the complex is paramagnetic or diamagnetic. When you can say that a compound is paramagnetic. Dear all, paramagnetic means they having unpaired electron, just odd electrons. If it is diamagnetic, if it is a diamagnetic one, they having paired electron like this. If there is at least one unpaired electron present, they are paramagnetic. If there are more unpaired electron, highly paramagnetic. If all the electrons are paired, 2, 2, 2, 2 like that, they are diamagnetic. Hope you clear that. So, sir, where we, in which step? Step 1, step 2, step 3. Where we want to find the unpaired electron or not? Step 3, at the end. In step number 3, at the end you can see 2, 2, 2. All electrons are paired, no unpaired electron. So, the complex is diamagnetic. Complex is diamagnetic. Hope you clear, dear student. I will go to second question. Let's make more practice, make more confidence. Next one. Question number 2. FeCN63 minus. Let's go to directly the steps. So, step number 1. Write the ground state. Okay, just a short form I am using. Ground state of the metal atom iron. Here the metal atom is iron, right? What is the atomic number of iron? Iron atomic number is 26. If the atomic number is 26, how you can fill the electron? You can write 4s2 3d6. Yes, student, up to 4s2 20 electron over. Remaining electrons 6 are there, put in 3d. That's it. Okay, let me go to step number 2. Step 1, step 2. In step 2, what you have to write? Ground state over. Let's go to the excited state. Excited state of iron. Please calculate what is the oxidation state of iron here. Iron oxidation state directly we don't know. X. Cyanide. 1 cyanide charge is -1. 6 cyanide charge is -6. Overall charge of the complex is -3. So, X is equal to +3. Dear student, oxidation state calculation, IUPAC nomenclature of this complexes, everything we discussed in the previous video. Please watch it. So, 3 is the oxidation state, which means iron is in 3+ state. What is mean by 3+? It has to lose outermost 3 electron. Let me remove this 2 electron, then 1 electron from 3d. Remaining is 3d5 and 4s0. In the excited state, please draw the diagram. Okay, 3d5 means the d orbital having total 5 electron. 4s having no electron. Let's go to step number 3. What do you have to do in step number 3, dear all? Can you remind me? Yes, in step number 3, first we have to identify the ligand given. The ligand is cyanide. Cyanide is, we discussed under, it's a strong ligand. If there is a strong ligand, electrons undergo pairing. Correct or not? Yes. So after pairing, what is the situation, dear all? All of you pair the electron. This is 3D and 4s. These two electron paired. These two electron paired. This one electron there. Can you tell me whether the complex is diamagnetic or paramagnetic? Yes. In this complex, you can see one unpaired electron is there. Therefore, it is paramagnetic. More unpaired electron, more paramagnetic. Okay. So, one idea, we already got it. This is what? Paramagnetic complex. Done. Next one, dear all. Next, what we have to do? Total how many ligands are coming to your complex? 6 ligands are coming to your complex. So you have to provide 6 vacant orbital to occupy them. At present, how many vacant orbital you have? 1, 2, 3. Not enough, right? 3 more is required. After 4s orbital, what do you have? 4p. After 4s, we have 4p. And those orbital which is occupied by cyanide ligand, please represent by this. 1, 2, 3, 4, 5, 6. Those orbital, mix it, dear all. What is these two orbital? D2. 2d orbital, right? This is sp3. D2 sp3. Same question in the previous one. D2 sp3 mean you can say that it is octahedral complex. You know, octahedral is nothing but square bipyramidal. Okay. How to draw the diagram of this complex or the geometry? Very simple, dear all. Here, iron is the metal atom. Cn, 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 Cn. Total 6 cyanides are there. You can see square bipyramidal. This structure is called tetrahedral. The overall charge is what? 3 minus. This is the geometry of the complex shape. Okay, so octahedral, dear student, D2sp3. D2sp3 means they took inner d orbital, right? Therefore, they are called inner orbital complex. Inner orbital complex. Tell me all of you fast. Inner orbital complexes are also known as what? Low spin complexes. What is mean by low spin complex, dear all? Low spin complex mean their inner orbitals will be almost paired. You see? Paired. And low spin complex means I told you there is a presence of, most of the cases, there is a presence of strong ligand. Yes, there was a strong ligand cyanide. And we already said because of the presence of this unpaired electron, the complex is paramagnetic. Third question. Carefully, there is a difference in this question, okay? Step number 1. Step 1, number 1. Write the ground state electronic configuration of the metal atom cobalt. All of you, cobalt atomic number is 27. 27 electron you can fill like 4s2, 3d7. Practice maximum, will get the speed, okay? And let's go to step number 2. Step number 2 is nothing but the excited state of cobalt. Please calculate the oxidation state of cobalt. Cobalt oxidation state is X. Fluorine charge, you know, -1. 6 fluorine charge is -6. Overall charge of the complex is -3. Here oxidation state is +3. So here cobalt is in 3+ oxidation state. What is mean by 3+? It need to lose outermost 3 electron. Let me remove these 2 electron and 1 electron from here. What is remaining? 3d6 and 4s0. Can you follow me? Right? 3d6. 3d6 mean how you can write? 1, 2, 3, 4, 5, 6. Let me just write once again. 6 electron. You can fill like 1, 2, 3, 4, 5, 6. And 4s, no electron. In step number 3, what you have to do, dear all? Step number 3, identify the ligand given. The ligand is fluorine. Dear student, halogens, I think we discussed under weak ligand. They are weak field ligand. If there is a weak ligand, in the previous 2 questions, there was strong ligand, we made pairing. Here halogen, fluorine, chlorine, bromine, they are weak ligand. They won't make pairing of electron. So what we have to do? Nothing. Just copy this structure once again. The excited state, just to copy once again without pairing. Okay. What is this orbital? 3d. This is 4s. What is the next step, dear all? Total how many ligands are coming to your complex? Total 6 ligands are coming. 6 fluorine are coming with electron. So you have to provide 6 vacant orbital. At present, how many vacant orbital you have? Only 1, right? Only 1. We need total 6. No problem. After 4s, what orbital you have? 4p. After 4p, what orbital you have? 4d, dear all. After 4p, 4s you have 4p. If you not sufficient 4p, take it 4d also. Total 6 site I want to occupy. So I can take inner orbital, okay? 1, 2, 3, 4, 5, 6. Those orbital, please mix it, dear all. This is an s orbital. This is total 3p orbital. This is 2d orbital. What is hybridization? sp3d2. We already said sp3d2 mean structure is what? Octahedral geometry. In this hybridization, did you notice? Here they took outermost d orbital for the hybridization. You know, d to sp3, we will call it as inner orbital, right? Because they are taking inner d orbital. Here inner d orbitals are available? No, because there is a weak ligand. If there is a weak ligand, this orbital not available. Because electrons will be there, they won't make pairing. Understood? So if there is a weak ligand, electron will be there. So we have to take outer d orbital. Therefore, they are called outer orbital complex. Outer orbital complexes are also known as what? High spin complex, right? High spin complex. You see, in high spin complexes mean the inner orbital or the orbitals are not paired completely, right? See that almost all unpaired electrons are there in the system. So outer orbitals complexes are also called high spin complex. High spin complex means there is a presence of weak ligand. Yes, our weak ligand is fluorine in this question. Whether it is paramagnetic or diamagnetic. Dear student, generally if there is a weak ligand in the complex, it will be paramagnetic. Not always, okay? We can say not that is like that. Most of the cases, if there is a weak ligand, you know, weak ligand, if it is there, these electrons are not making pairing, right? They will exist as unpaired electron. So this is our highly paramagnetic. See, total 4 unpaired electrons are there. This is highly paramagnetic. Paramagnetic in nature. Now we discussed only related to octahedral complexes, right? Let's go to what are the other two structure? Tetrahedral and square planar. Let's see. One example for each. Here the complex we have NiCN4 2-. You can see only 4 cyanides are there. 4 is the coordination number. I told you 4 is the coordination number, either tetrahedral or square planar. Method is same, dear all. Step number 1, write the ground state of the metal atom nickel. Nickel oxidation state is, atomic number is 28. So the configuration we can write it as 4s2 3d8. Step number 2, let us write the excited state of the metal atom. Dear student, nickel oxidation state, we don't know X. 1 cyanide charge is -1, so 4 cyanide charge is -4. Overall charge of the complex is -2, so X is equal to +2. So here nickel is in 2+ oxidation state. What is mean by 2+? It need to lose the outermost 2 electron. What is remaining? 3d8 and 4s0. 3d8 means you can write the electrons like this: 1, 2, 3, 4, 5, 6, 7, 8 and 4s0. What is step number 3? In step number 3, we have to identify the ligand. The ligand given is cyanide. Cyanide is a, good dear all, it's a strong ligand. If there is a strong ligand, electrons undergo pairing. Electrons undergo pairing, right? So after pairing, what is the situation? After pairing, what is the situation? These 3 set is already paired inner side. These 2 electrons paired. Done. Can you tell me whether the complex is paramagnetic or diamagnetic? All electrons are paired, no unpaired electron. Therefore, it is diamagnetic, right? This complex is what? Diamagnetic. Let's calculate the hybridization, dear all. Total how many ligands are coming to your complex? 4 ligands are coming. If there are 4 ligands coming to your complex, you have to provide 4 vacant orbital. At present, how many vacant orbital you have? 1, 2. You need 2 more, right? Take after 4s, what is free? 4p. So let us, this 1, 2, 3 and 4. Mix it. Can you tell me what is a hybridization? This is a d orbital, s orbital, 2p orbital, dsp2. Already we discussed in the beginning, dsp2 means the structure is what? Square planar. Square planar structure, right? dsp2, square planar. How to draw the diagram? Very simple. What is square planar, dear all? Here the metal atom is nickel. You know, square planar means cyanide, 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 cyanide. Total we have the charge of the complex is 2 minus. Maintain the structure, the charge. This is the square planar geometry. Clear all? Next question, last one, dear all of you, please listen carefully. I will go to step number 1. Same, write the ground state of the metal atom nickel here. Nickel atomic number is 28, so I can write the configuration 4s2 3d8. Step number 2, write the excited state of nickel. Here nickel oxidation state X, 4 chlorine charge is -4, overall charge is -2, therefore X is equal to +2. So we can write nickel, here it is in 2 plus oxidation state. You know, 2 plus mean outermost 2 electrons gone, remaining is 3d8 and 4s0. 3d8 means how we can fill the electron? 1, 2, 3, 4, 5, 6, 7, 8 and 4s0. Step number 3. Step number 3, identify the ligand. The ligand is chlorine. Dear student, halogens are weak field ligand. If there is a weak ligand, electrons won't undergo pairing. Please copy the same one. This is 3D. And 4s. Done. How many ligands are coming to your complex? Total 4 ligands, right? If 4 ligands are coming to your complex, you have to provide 4 vacant orbital. At present, how many you have? Only 1. Take after 4s, you have 4p. Those orbital represent by 1, 2, 3, 4. Those orbital mix it. This is an s orbital. This is 3p orbital. What is hybridization, dear all? sp3. sp3 hybridization means we said the structure is what? Tetrahedral complex. Inner orbital, outer orbital, everything they will ask you only in the, mostly in the octahedral complexes. Okay. So this is tetrahedral complex, whether it is paramagnetic or diamagnetic. You see, dear student, 1, 2. Especially, of course, this is a weak ligand, right? Weak ligand, if it is there, electrons won't undergo pairing. Unpaired electrons will be there. They are paramagnetic. Right? They are paramagnetic. What is the geometry we said? Tetrahedral. Can we draw the structure? Yes, of course. Here nickel is the central atom. What is tetrahedral geometry? This one. What is the ligand? Chlorine, 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 chlorine. What is the overall charge? Overall charge is 2 minus. NiCl4 2 minus is the complex. Clear all of you? The step is very simple. The steps. See the step 1, step 2, step 3, step 4, the same thing we have to discuss again. So if you know the table, means what is a hybridization and the corresponding structure. If you know this concept, means octahedral, there are 2 types, inner, outer, low spin, high spin, whether a strong ligand, weak ligand present, everything, even magnetic property, whether it is para or dia, everything you can explain through the help of which theory, dear all? VBT, Valence Bond Theory. So keep practicing, all of you. So we will meet again with some more concept from the other chapter and also the coordination combo, the other concepts. So those who don't know what is the charges of ligand, how to calculate the oxidation state of the metal atom and the IUPAC nomenclature, see our first video for the chapter. We'll get a continuation. So first of all, see that IUPAC nomenclature video, then come to Valence Bond Theory. Hope you clear how to calculate all these topics: shape, magnetic property, inner, outer, low spin, high spin, everything regarding coordination complexes. Thank you all. See you again.
Brilliant, Qatar. your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar. Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.